Today's presentation is being presented by Ziha and Caleb, and we are going to introduce our civil engineering and construction database. So firstly, for the application domain, the area is basically for civil engineering construction company and also some construction factories, and even the research labs regarding the civil engineering topics for through any universities or even some institutions. So for our challenges, because from my experience, a lot of engineering companies and research institutions, they normally experience a lot of work to record and manage the data from the lab tests and also the project they work on, and also their employee informations. So those data are currently installed by handouts and some created Excels, so they are not well organized and cannot be accessed easily. So a database right now can be produced to help the company and the lab to better analyze and track the status of the lab experiment situations of different project, so they can save the cost and also finally help the company labs run more effective. So this is our old ER model. So basically, we have the lab engineers project, financial office storage, totally five entities, and also the attributes around each entity, where has the relationships which are worked on and managed that can consist of this total ER model. So our new ER model, which is the only thing changed, is we add a SID storage ID to the storage, so we can have better relationships to present that which engineers can more specifically responsible for which storage. So for our problem statement, firstly, we have five entities as from the ER model, and we have each entity has their own attributes. So for engineers, is basically record for the basic information from engineers and their ID, and also the lab will record the each lab ID, test ID, and pay ID, and also the lab progress, materials, equipment they use. And storage will basically be responsible for record the amount or any situations regarding equipment and materials. Project ID will be responsible to record any progress equipment they use for any specific project. And the last one, financial office, will be responsible for supporting the financial stuff for engineers, lab storage, and also will record the cost and the income for each transactions they made. So here for our relationships through these entities, and it's quite simple. It's only we'll have the engineers manage the storage, and also we'll have relationships for engineers to work on the lab test or project. So for our entity relationship constraints, we have basically for four constraints. So firstly, each lab will need exactly one engineer to manage, and also the storage has the same constraint that need exactly one engineer to manage, and also to ensure the efficiency. And each project can only have most five engineers to be responsible, and for projects, each engineers can work on at most two projects at the same time. So for the integrity constraints, so firstly, which is the most important one, that all the information recorded cannot be null, which means we need to have more specific data in order to not to produce any error. And also the secondly, as from the entity constraints, we need one manager for each lab and only one. And also only three engineers can be assigned to a test at the same time, and only five engineers assigned to a project can work at the same time.
This database uses numerous foreign key restraints, some of which are used in more than 2 tables. Below is the engineers table, which contains most of the IDs in the database. Because it's possible to edit tables in this database that would result in anomalies, this database does not meet the requirements of BCNF. See, below we have the lab table and the lab manager table, both of which share IDs with the engineers table. So if they were edited, they would result in mismatches. So this violates BCNF. Here is a trigger example, the trigger being only 3 engineers assigned to a test at a time. On the right is the code. It uses a before insert on the engineers table and uses an if statement to check the count of engineers that have the matching test ID with what you're inserting. If it is greater than or equal to 3, then it will throw up an error message. You see the example below. There's currently 2 engineers with the test ID of 1. I insert 1 and it works fine, and then I insert another, which brings it up to 4, and it throws up the error message. Here's a view example from the database. This simply combines the management table with the lab table. It has the information from the lab, and under the name column, it has the manager for that particular lab. And here's the distribution of work for our database. Zhao did the preliminary design, the old and new ER model, and the DDL commands. Together we collaborate on the entity relationship model, the data dictionary, and the constraints. And I designed and coded the triggers and checked our database if it met BCNF requirements.